Hello everyone and welcome to Frogs, Fleas, and Painted Cubes 2.2. Our learning target today is that we want to be able to change from factored form to expanded form. So we look down here, our ACES questions for 2.2 are 3 through 31 and 57 through 58. Now if you open your textbook to page 28, we can follow along here. And what we're really working with today is, as it says here, the distributive property. So this might go on for a little while today. We have quite a few vocabulary terms and a real introduction to practice of the distributive property with quadratic functions here today. So, and then the last problem, it says you looked at two expressions for the area of a rectangle, n minus 2 times n plus 2 and n squared minus 4. Now these two expressions describe the same area, they're equivalent, so it means that we could rewrite it like this, that n minus 2 times n plus 2 equals n squared minus 4, and that's going to be true for every value of n. So let's take that and go to the next step where we have another example of equivalent expressions down here. It says, suppose a square has sides of length x centimeters. One dimension of the square is increased by 3 centimeters to make a new rectangle. So we start out with our square, and both sides obviously are labeled as x. So if we were going to find the area of this, it would be x squared, okay? X squared. Well, we still have our square in here, so we're going to go ahead and put this part as x squared, but now we have this other little rectangle added on to it. And I said added on, so we're going to wind up using a plus sign here. But the area of this little rectangle is, we take our width of 3 times our length of x, so now we have this as 3x. Well, to put these two together, we would have x squared plus 3x. And that is the whole area. Well, there's another way we could write this. We could factor out an x. So we're going to go ahead and write x. And what's left, if we take one of the x's from here, we have an x. Take the x from here, so we have x plus 3. Okay? So these two are equivalent. X squared plus 3x is equal to x times x plus 3. And down here it says, how do the areas of the square and the new rectangle compare? Write two expressions for the area of the new rectangle, which is what we've done right here. Hopefully you can see how that was done as we turn our page and we see that x squared and 3x are here. Now both of these are examples of quadratic expressions. And quadratic expressions, as we look here, are expression that is equivalent to an expression of the form ax squared plus bx plus c. That's the big form that we want to pay attention to with our quadratic expressions, is ax squared plus bx plus c. I'm going to allow you to give you time to pause the video right here and read through the rest of this. Take notes, please. Write down the definition in your notes, so when we go to have an open note assessment, that you're able to come back to this if necessary. So go ahead and pause the video here and take the notes you need. Okay, coming back, now we continue on with an expression in factored form is quadratic if it has exactly two linear functions, each with the variable raised to the first power. We'll discuss that here in just a minute. An expression in expanded form is quadratic if the highest power of the variable is 2. So the factored form would be like this sort of expression, and we can draw our lines to here or here, and our expanded form is going to be this other type. Okay, and let's take a look at the actual vocabulary definitions of factored form and expanded form. So as we go back, we have both factored form and expanded form here. Again, I encourage you to pause the video and write down the definitions here for factored form and expanded form in your notes so that you can refer back to these at a later time. Okay, and welcome back here. Hopefully you can see that in factored form we've grabbed a common factor out of our original expanded form. That we've taken an x out of those. We've factored an x out of that, and that's how we get the name factored form. As we continue on here, we talk about the distributive property, and the equation x times quantity x plus 3 equals x squared plus 3x is an example of the distributive property, which you did study in earlier units, but to reflect back on the definition of distributive property down here. Mathematical property used to rewrite expressions involving addition and multiplication. Distributive property states that for any three numbers a, b, and c, a times quantity b plus c equals ab plus ac. If an expression is written as a factor multiplied by a sum, you can use the distributive property to multiply the factor by each term in the sum. And we've talked about this a little bit, that if we had 4 times 5 plus x, we would have 4 times 5 plus 4 times x. So we'd have 20 plus 4x. Again, pause the video, take notes, and be ready to refer back to this at a future time. Okay, and we get a visual of the distributive property here. We have a width of A on this square and a length of B on this square, and then when we add the rectangle, we have a length of C. And we know that with our area, that length times width, we're going to have A times B is our AB, and then for this part, we're going to have A times C as AC. And another way we can write that is A times B plus the A times C. So A times B plus C. So we could just add the lengths of B and C together and multiply by A, and it works out the exact same way. Now, they're asking us if we can use a distributive property to show that n minus 2 times n plus 2 equals n squared minus 4. So using your FOIL terms, can you pause the video and show the steps necessary to do that? Next, we're going to talk about terms. The terms 2x and 3x are like terms, and we can use the distributive property to add like terms. Definition of term is any number, a variable, or the product of a number and a variable, and then like terms are terms with the same variable raised to the same power. So in the expression 4x squared plus 3x minus 2x squared minus 2x plus 1, this 4x squared and the negative 2x squared, they are like terms. They can be combined. 3x and negative 2x are like terms. They can be combined. So now we're getting ready to get into the problems if you've read through everything. And as we take a look on page 30 at problem 2.2, what it wants you to do is look at each of these things and write two expressions for the area of the rectangle outlined in red. So outlined in red in factored form and one in expanded form. Okay, your red here. So I'm going to jump ahead here. You guys can do 1 and 2. I'm going to jump ahead to number 3 here and hopefully give you a little bit more visual of how this works. So we have this rectangle divided up into 4 other shapes, and we have a square and then 3 rectangles here. So in the first one, to get the area here, we have x times x for our length times our width. Okay, so we have x squared in here. On this one, we have a length of 5 and our width of x, so our area is going to be 5x. Up here, we have our length of 5 and our width of 2, so 5 times 2, this area is going to be 10. This one, up in here, we have our width of x and our length of 2, so this is 2x. So now we need to add all of these together to get the total sum. So we're going to start with the largest power of x squared, and we'll add in our 5x, okay, and our 2x, and our 10. So we add all of these together, okay? And when we do that, we get x squared plus 5x. Oops, sorry, let me undo that. I was just rewriting everything. So we're going to combine 5x and 2x. That gives us 7x, and this is a plus. I know I'm writing with my right hand, so it's not very good. I apologize. So we'll make this an ugly plus, or I can grab this, make it a little better for you, hopefully. Sorry about that. Okay, that's one of the ways we can write this. The other way we could write it is in our factored form. We would have x plus 5. Okay, so that's on this side. And then on the other one, we have x plus 2. X plus 2. And that would be our factored form. So hopefully that gives you an idea. Play this part back as many times as you need to help you get through 1 through 6 here. And then part B, I want you to use the FOIL method that we talked about in class the other day to expand these factored forms out. And in D, again, we're just gonna do 2, 3, and 4 in D here. More practice for you. On E, we're going to do 1 and 3. So 1 and 3 here to finish those out. And we're not doing anything with 5 here. So skip that. So hopefully that'll get you some practice, some understanding, and then again our aces for 2.2 is 3 through 31 and 57 and 58. Hope that all makes sense. I know it's a lot of information. Hopefully you can pause the videos, play them back, take notes, get some practice with that. Hopefully I didn't confuse you too much, and look forward to hearing your questions and comments in class.